Good morning to you. Any question? Let me know. Geo plus graphy. Earth discussion. Right, to discuss. That is how we were talking about it as spatial science. Right, science of space. Location. Answering why with respect to location. And in the process, we learn and we need so many other things as well. Now, what is Earth? All of you know? What is Earth? Earth is a planet. Right? Earth is a planet. What is planet? What is a planet? Which revolves around the sun. Anything which revolves around the sun. Are we revolving around the sun? So we are also planet? We are also object. Write down. A planet is a celestial body. Any celestial body revolving around a star. Any celestial body revolving around a star with enough mass and gravity revolving around a star with enough mass and gravity not only to maintain its own shape, but also have the capacity to clear its own orbit. Now there are two parts here. You can see that mass and gravity, right? Mass gives you shape. So to maintain its own shape, and the gravity to clear its own orbit, Now, this is the addition, new addition in the definition of planet. Earlier it was just any celestial body revolving around a star is called a planet. Now these two are additional information, especially in 2006, when discoveries suggested that beyond Neptune, there were a lot of other planets-like objects, right? So if they would have included all those just with the simple definition, there would have been more than 2,000 planets. And they knew that UPSC guys have to remember it. So just change the definition to reduce it to 8, and the Pluto is no more a planet. So with a new definition, Pluto is not a planet. Now, clearing its own orbit, what do we mean by that? We all know that any celestial bodies revolve around an orbital plane, like Earth may be here, sometimes here, and so. So, this is called orbital plane or orbit, right? Within this, anything should not exist. If anything comes, it should be an integral part of the planet. Only then it will be called planet, right? Suppose Earth is here, anything is entering here and staying, suppose. So if it is coming, it will be an integral part of it. It will pull it down and make it an integral part. And that's what enough gravity to clear its own orbit. Nothing should exist in the orbital plane without the consent of the celestial body. Only then it will be called a planet. Are we clear? Sure? Right? So Pluto, like why Pluto is no more a planet. So if Pluto is here, there are other smaller bodies existing in the same orbit. And it is revolving. Pluto is also revolving. Other celestial bodies, small celestial bodies are also revolving here. So Pluto will not be a planet. Right? So earlier, what was the definition of the planet? Now it is called dwarf planet. Dwarf planet. So any celestial body just revolving around a star. Revolving around star, right, without having the mass to maintain the shape, but not the gravity. Not enough gravity to clear the orbit. So they will be called dwarf planet. Like Pluto is a dwarf planet. So any celestial body revolving around a star. What is a star? Which emit light on their own, which produces energy. And some part of energy is seen in the form of light. Like Prabhash. Right? He emits, that's why he's called a star. Superstar, right? Rajinikanth. Amitabh Bachchan. What will you call Jayalalitha? Not Amma. A dead star. Right. So a star, what is a star? The celestial body which produces energy. Its own energy. A part of that produced energy is seen in the form of light, right? Which produces energy through the process called nuclear fusion. How? Fusion means joining. So hydrogen plus hydrogen makes helium. In this process, it releases energy, and a part of that energy is seen in the form of light. And that's what you call a star. Every star has its own birth, grows, becomes old, and then dies. And that's what you call dead star. This is what you call a red giant. Birth has an evolutionary process. We'll have solar system discussion later. We're just having a glimpse of it, which is needed. Once a star is born, it has fixed amount of hydrogen. Fixed hydrogen. Right. There is a continuous depletion of hydrogen through fusion. Right? Just like we are bleeding or our cells are deteriorating with age. So with the stars, hydrogen is depleting through this process. So there is a continuity of this process, and a regular formation of helium leads to depletion of hydrogen. Right? And that's why after a point of time, it is left with very less amount of hydrogen. And then the star is considered as old, and they are called red giant. Right? Giant means bigger size. And red because of higher wavelength, that energy emission is less, so only red is visible because of longer wavelength. And that's why it is called red giant. Good morning. If you need to talk, I'm expecting you to do so. Sometimes I might be very fast with the assumption that it is very easy and you are understanding. My assumptions might be wrong. So you need to prove that I was wrong. Right? So, in the evolutionary process, what we are trying to discuss is a process of formation of a celestial body, star formation. Right? In the formative stage, a star has whatever amount of hydrogen is left with, it will keep on depleting continuously. Right? So when hydrogen is transformed into helium, after a point of time, good amount of hydrogen is depleted. And because of that, the amount of energy released will be less. And the color of the star will become red. So we call it red giant. So red giant is the stage of a star where it is old. Sun is expected to become red giant in the next 4 billion years. Somewhere it is 4.5 billion years. Right. Then dead star. Death of a star may be in two ways. Through the natural process. Just like birth, red giant, and death. Sequential order. But they may be accidental also. Just like humans. Like we are born, grows up, become old, and then die. And then there are accidents also. So the accidental deaths in a star, in both the cases, it is depletion of hydrogen. Always remember this part. Depletion of hydrogen. Right? Hydrogen is exhausted, then stars will be considered as dead because they are not releasing energy anymore. So they will not be considered as star. In the natural process, when a star dies, they are put into three categories depending upon their density. White dwarf, neutrinos or pulsars, and black hole. So all the stars which are dead will be put into these three categories. What is the most prominent thing is density is increasing. Gravity increasing, in that order. Both density and gravity increases. A black hole is considered as the densest object in the universe. Highest gravity. Of any object known to humans, black hole have the maximum gravity. Because of its high gravity, it pulls sometimes the object, including stars, passing nearby. Sometimes the entire star system itself. Sometimes it eats out the entire star and its family, like in our case, solar system. That's why they are called. Hence, black holes are also called. Hence, they are also called star eaters. It is estimated that 1 spoon soil of a black hole will weigh many tons, 50 tons at times, on Earth. Imagine the amount of gravity it has, the compactness it has. Accident. Accidental death or accidents in a star. There are two types, not necessarily death. Accident in a star are of two types. Partial. Complete explosion. Partial explosion or complete explosion. When the hydrogen on the surface quickly get transformed into helium. So only superficial hydrogen is transformed into helium much faster than the normal. That's what you call explosion. Explosion means higher rate of fusion. Explosion is in a star means much higher rate of fusion than normal. That is higher rate of conversion of hydrogen into helium. This is partial explosion. They are called nova. So when the star experiences partial explosion sufficient enough to deplete the hydrogen on the surface in one go, that is called nova. Right? When we say quickly, it doesn't mean the 1 day or 1 second or 2 seconds. It may take years, earthly years. But that is much quicker than normal. That's called nova. When there is complete explosion, means entire hydrogen converting into helium much quicker than normal. That's called supernova. Which one will be brighter, nova or supernova? Supernova, right? Which will give you red giant, nova or supernova? Nova. And after supernova stage, the star will be dead or old? Dead. That's how the questions will be framed at times. The questions are relatively less from astronomy nowadays, but just these basics you need to have it. The difference is nova and supernova. Now let's come back to the definition of universe. For the first time, when the systematic study of the celestial bodies started, the entire celestial body, the geographers or the scientists called it universe. And the study of universe was called astronomy. Later on, the same was named as cosmos, especially with the French influence. And this study is called cosmology. Scientific study of the cosmos is called cosmology. Nowadays, the popular word is space. And the study is called space science. All are similar. Whether you call it astronomy, cosmology or space science, universe, cosmos or space. The only difference is nowadays we are differentiating between space and outer space. Outer space, which earlier was not well defined. So when you have Earth and the atmosphere, so area beyond it is outer space. Space includes Earth and atmosphere. So outer space is equal to space minus Earth atmosphere system. Earth atmosphere system is outer space. So space is the entire universe or cosmos. Outer space is space minus Earth atmosphere system. That things beyond Earth atmosphere system is outer space. So whatever you call it, a universe, cosmos, or space, how do we define it? Or space, whatever we call it, how do we define it? What is universe? What is space? Collection of millions of billions of galaxies. Collection of millions of billions of galaxies. Right? What are galaxies? Collections of millions of billions of stars. Right? Each star has its own family, held together by the force of gravity. That's what we call star system. In our case, we call it solar system, as our star is sun. Which is the nearest star from Earth? Proxima Centauri or Alpha Centauri? Or sun? That's UPSC has asked once, and most of the students have committed mistakes. Which is the nearest star from the solar system? Proxima Centauri and Alpha Centauri. Both comes because of its parabolic path, elliptical path. Sometimes it is Proxima Centauri, sometimes it is Alpha Centauri, the star system which is closest. But from the Earth it is the sun. So we have all the star system. Now, in a single galaxy we are living in is called Milky Way. By the Britishers, in Hindi or Indian we call it Akash Ganga. Chinese call it Heaven's Path, and different countries have different names. So the galaxy we are living in is Milky Way or Akash Ganga, which is supposed to have more than 2 billion stars. 2 billion stars in this galaxy itself. And there are millions of billions of galaxies yet to map properly the number of galaxies in the universe. Imagine that. And in that more than 2 billion star in Milky Way, one star is sun. And out of the million of other celestial bodies within solar system, Earth is one planet. Right? Among the 8 major planets we have Earth. Minor planets we have a lot of minor planets. Now within Earth just 7% is occupied by Homo sapiens. We are yet to properly identify the number of species found on the Earth. Imagine the limit of humans. Right? We are not able to map properly the solar system. The Earth, forget about the solar system. We don't have actual good amount of idea about the Earth itself. When Corona came, everybody got lost. One small virus showed the place of humans, and all the scientists, all the biologists, all the chemists and all, right? But forget about the Earth, solar system, Milky Way, and then billions of Milky Way in the universe. But we are very sure about who has created it. Isn't it? Who has created it? तुमने नहीं बनाया ना? ये श्योर हो गया, चलिए इसने नहीं बनाया. God, Allah, Bhagavan, whatever you call it. And when you go deeper into astronomy, you will realize that how dwarfed we are. Even the best of the scientists, you can say that. So in general, what is we are discussing is universe is made up of millions of billions of galaxies, right? Each galaxy may contain billions of stars, and each star may have several planets. In the case of solar system, we have 8 planets, and one of the planet is Earth, right? We'll come back to that later. Earth is a planet, right? Inhabited by the only known planet we can say that, which is inhabited by biotic communities, right? Now, what is the shape of the Earth? It's called geoid, right? Geoid. Geo plus ID. Show me your ID. Geo ID. What do you mean by that? Earth has its own ID. Earth has its own identity. In what sense? Shape-wise. Right? So that's why we call it Geo ID. Earth has its own identity with respect to shape, which does not resemble to most of the shape we have on the Earth. That's why it is called, it has unique identity. And that is what is called Geo ID. The closest to the shape is either an orange or an onion, right? So what is the uniqueness of its identity? Flat at the axial point. At the axial points, which we call poles. It is flat at the axial points and bulging in the central area. Bulging in the central area, which we call equator. Right? Earth flat on the poles and bulging in the central area. We call it equator and we call it North Pole and South Pole. You all might be knowing. Why is this shape? Whatever uniqueness it has about shape, why is it? Because of rotation. That is one of the movement of the Earth. Because of the rotation. Right? Any rotating body will experience two types of forces. All you know? Centripetal and centrifugal forces. Imagine Earth as a plastic body, and when it is rotating on its own axis, there will be pressing from this point and this point. So just as a balloon, if you press it, there will be bulging in the central part. As simple as that. Right? So because of rotation, this shape is created. The reason for the uniqueness of the shape is rotation, where the centripetal force creates flatness and centrifugal creates bulge. What is the consequence? Consequence, radius is not equal. Radiuses are, or radii are not equal. That is, from the center of the Earth, every point is not equal. Right? Farthest point is at equator. Farthest at equator and closest at poles. from the center of the earth. So, in this sense, not a perfect sphere. Not a perfect sphere. That has its own problem. But for all practical purposes, for all practical purposes, it is treated as sphere. Who discovered America? Columbus. What had happened with him? He was not interested in discovering it. He wanted to come to and ended up landing at West Indian Islands. Right? Why? Because of the lack of direction. That's the problem of a sphere. On a spherical body, it is difficult to have the direction. To understand the direction on a spherical body is extremely difficult. Right? For that, the geographers established what we call grid system. Our GPS works with this grid system. Right? With two lines, latitude and longitude. This is called grid system. So Earth is divided into several parts where the lines are drawn from pole to pole, we call it longitude, and parallel to the equator we call it latitudes, right? Technical definition, both of them are angular distance. Angular distance from the center of the earth. From the center of the earth. With respect to each other. So we will define latitude as the angular distance from the center with respect to longitude. The longitudes are angular distance from the center with respect to a particular latitude. How will you draw? Imagine Earth, how will you draw latitudes and longitudes? You will have to place yourself in imagination at the center of the earth. Right? And in the center of the earth, then you draw. Equator is naturally given. Right? Because it equates. Anywhere if you take other than this point, which is called 0 degree latitude, anywhere you take, you can't divide the earth into two equal halves. So it is naturally given. The only option is you have to take this bulging area as 0 degree. And then you cut it out in different parts, northward and southward. Right? Imagine an onion. And if you are a good chef, you can make slices. Right? So that ways, earth is divided into 90 part on the top, 90 part in the below. And all these are called latitudes. Each latitude is further divided into minutes and seconds also. 60 minutes, 60 seconds also. So that at the micro level, the location can be established. right? So when you divide the onion into different slices, can we say that the thickness will always be equal, but the circumference will keep on decreasing? Hope you understand that. So all the latitudes are parallel to each other, because roughly the distance between the latitudes will be equal, and that's why they are also called parallels. So latitudes are also called parallels because they remain roughly parallel throughout, right? Equidistant. They are equidistant, but varies in circumference. Equator is the largest circle. -60° latitude is half of the equator. 75° latitude is 1/4 of the equator, and 90° latitude is just a point. Whereas longitudes are like scientists were free to draw the 0° latitude or the reference latitude. From there they can have the reference, but there was no option here. 0° has to be the central part, which we call equator. Then it keeps on decreasing and goes to end up as point, right? Keep on decreasing, ending up as a single point. This is how you have. How many latitudes are there? Major latitudes? How many latitudes are there? There are no latitudes. 8 latitudes. Which are they? So 1° is not there. How many latitudes are there on the earth? 180. 181. 181. Among the major one is, we're talking about Tropic of Cancer and Capricorn and Arctic and Antarctic. So 181, 90 above, 90 below, and 0 as common. Very basic question, but sometimes asked. So we have altogether 181 latitude, right? The longitudes are not parallel. Right? But they are divided again 0°, which is called prime meridian. Longitudes are also called meridians because they are equal in length, unlike latitude, which are not equal in length. Longitudes are equal in length. Not equidistant. So, not parallel to each other. Distance in between them. Distance in between keep on decreasing. From the equator to the poles. To the poles. Hope we are getting it. If you look at the equator and the two longitudes, they will converge and come close. So the distance will keep on decreasing. That is what you will read in the books. Now, if I ask you a question, that distance between two longitudes will always be equal along a particular latitude. I'm telling you, I'm not asking you. Now I'm asking, do you understand it? The distance between the two longitudes will always be equal along a particular latitude. So if we take any latitude, the distance between the longitude will be equal. Though it will keep on decreasing towards the pole, but along a particular latitude, it will always be equal, right? So that's how the twisted version of that may come. There is a term in grid system is called great circle. Circle dividing the earth into two equal halves. Any circle dividing the earth into two equal halves. This is called hemisphere. Half of a sphere. Hemisphere. Two equal halves are called great circle. Do you understand? Any circle we draw on the earth, if it divides the earth into two equal halves, we call that circle as great circle. If I again ask you, now I'm asking, all the latitudes are great circles. True or false? False. No latitude is a great circle. Equator is the only latitude which is a great circle. All the longitudes are part of great circle. All the longitudes are part of great circle. That's true, right? Among the latitudes, only equator is the great circle, right? What is a great circle? Which divides the earth into two equal halves, and we call it hemisphere. Hemispherically, earth can be divided into how many parts? Only two. 4 parts. Northern hemisphere and southern hemisphere. That is one way. How many ways earth can be divided into two equal halves? Look at this. How many ways you can divide it into two equal halves? Many ways, infinite numbers. Infinite. Can you understand that? Infinite. However, we commonly use two ways. Northern hemisphere and southern hemisphere latitude wise. Eastern hemisphere and western hemisphere longitude wise. So we have prime meridian connected with the 180 degree. This is called, this will make great circle, right? So prime meridian is 0 degree and great circle, or the opposite side will have 180 degree. So this side you will have eastern hemisphere if you are looking at the prime meridian. Right side is eastern hemisphere, left side is western hemisphere, right? India lies in which hemisphere? Northern hemisphere. Very common question in interview. Do you imagine that this question is asked in interview? And why it would be asked? India lies in which hemisphere? Northeastern hemisphere. That's the only thing. How conscious you are about. So very often this famous division is northern hemisphere and southern hemisphere. So this is geographical north-south division. Sometimes you have economy also north-south division. That is about developed countries and developing countries. In economy, north-south division is developed countries and developing countries. In geography, north-south is northern hemisphere and southern hemisphere. Movement of the earth. What are the movements? How many ways earth move? Rotation and revolution, right? This two common famous are commonly found is rotation, revolution, and the third one, which is not very common, is galactic. There are three important movements in the earth. There is a term called earth movement and movement of the earth. These are two different things. Earth movement is movement of the particle of earth within its own body. It's called earth movement. Movement of the earth means the movement of earth as a single entity, as a one single coherent body. Right? Rotation is what? Earth is rotating as a body. When you have landslide, this is movement of particles within the body of the earth. Magma rising up. This is called earth movement. When the particles move within the earth, particles move within the earth. When earth move with reference to other celestial bodies. Or as a single body. Let's pick up rotation. What is rotation? How do we define? Movement of earth on its own axis. Right? So it is spinning. Earth spins on its own axis. So spinning of the earth on its own axis. On its own axis. Spinning, just like a top. What is axis? Imaginary line. Aage. Fixed path. That is orbit. We're talking about axis on which it is rotating. सुबह सुबह तुम लोग दारू तो नहीं पीते ना? Good. शाम में पिया करो. Imaginary line. Good. All of you know it. What is the problem? You cannot define it because you haven't learned properly how to put your words on paper. That's why I keep on asking and keep on trying. Where it is coming or not, this is a part and this is a process of learning. Even the basic thing I'm asking, very often you know everything, but you're not able to put before the public. And you need to learn that. So what is an axis? A imaginary line passing through? Why are you complicating it? Two equal halves. That is great circle. Axis. Parting? Joining two poles. Passing through the center of the earth. Right? All of you knew it. Right? So the problem is that it is there in your mind, but you haven't learned and you haven't trained your mind to put it before a speak out. So connection of thought and tongue. You need to practice. Right? It might appear very easy, but it's not that easy. Right? Very often you will fail to answer to someone if they are asking questions to you just because of lack of training. And that will happen in the mains also. That will happen in the interview also. Don't ever think that you will transform yourself within a month or so at the time of interview. Right? It might again be premature to tell you that you think about the interview. How many of you are really thinking about the interview? Sharma mat. And rest of you, what are you doing? We have 3 stages, right? Prelims, mains, interview. Which would be the first to prepare? Prelims? Okay, let me tell you a sequence. Prelims, mains, interview. Mains, prelims, interview. Interview, mains, prelims. You told mains, prelims, interview. Rest, prelims, mains, interview. Mains, prelims, and interview. Please close your eyes. And think a tree of your choice. Did we do that? Did we have this experiment in the last 3 days? Experiment it. Just close your eyes, please. And think a tree of your choice. Any tree of your choice. Close your eyes. Watch it properly. Watch it properly. Sometimes behaving like a kid is a great idea. So don't consider yourself adult one. You are not right now. Keep on watching. The next 30 seconds, just keep on watching the tree of your choice. Open your eyes, please. Anyone who has watched the root of the tree? Honestly. It's only few. What is the most important part of a tree? And most of you didn't see that. That's the basic human mind. Easy going. Right? So the basic human mind go the easiest way. Whereas all of you would have started from the top. And then would have gone like this. Might have watched the branches and the trunks and maybe fruits. And then stopped at the surface. None of you would have tried to go deeper. Or very few, it's like 4 or 5 of you have gone through that. The same happens with this. The first stage is interview. Then mains. Then prelims. This is the real sequence of preparation. Now, you'll say that you are not preparing for interview. All of you are preparing for interview much before you thought about your UPSC. What is interview all about? Your personality, right? How do you behave? How do you react to a situation? How do you treat your elders? How do you treat your youngers? Right? What is the bend of your mind? How religious you are? How fanatic you are? Right? What is your opinion about the international issues? Whatever you have learned or you have read? Whether you just get carried away, you are tempted, you are reactive, right? Your view about the society. And believe me, everything will be done out of you, your body. You might feel that you can trick it. There are a few who can trick it, but they also need to practice. Right? So, whatever you are doing right now is a part of your interview, unknowingly. Do it consciously. What is interview personality all about? Officers like quality, right? They'll be searching in you. They'll be searching in you how disciplined you are, how obedient you are, how honest you are. What is the level of your moral and ethical standard and all. That's all about the personality. And you have to cultivate it over the period of time. Again, don't ever think that you can transform yourself, your personality within 2, 3, 4, 5 months. No, it is impossible. So start thinking like an IS officer. You're preparing for interview, even without knowing. And then obviously mains. Because when you have broader picture, then to take out the smaller one or to reason into it, to if it is twisted, if you have prepared for mains, it is easier to do the questions, objective questions, if you have the subjectivity on the topic. So the sequential order is interview, mains and prelims. All of you are preparing for interview much before you open your book. The only thing is that you don't know. Now do it consciously. Start believing in yourself. Start behaving like as an IS officer. There are two ways to behave: responsibly and bluntly, like raising your collar, I'm an IS officer. That is shallow personality. Right? Thinking as I'm an IS officer, I have a lot of responsibilities. That is the real personality. Then if you're thinking as an IS officer and going to kick a rickshawala as an IPS, so that is shallow personality. Again, behaving like an IS officer at two perspectives. Treat yourself as an IS officer. The moment you get up early in the morning, think you as an IAS or IPS officer. You will see the level of your motivation. You will see the level of your productivity. It will be transformed. Right? What we were discussing? Axis. So what is an axis? Is the imaginary line joining both the poles passing through the center of the earth. Right? Now there are few properties of axis. First is axial inclination. We know that axis of the earth is not straight, not normal, rather inclined. What is the inclination? Like normal, this is the axis. The earth should be like this with reference to sun, but it is right now like this. Inclined at 23.5 degree. Right? Now, this is the present case. However, scientists have proven that axial inclination change over the time. Changes with time. From 22.1 degree to 24.5 degree, or roughly around 22 to 24, maybe in 1 lakh years, but it changes. It keeps on changing. One of the natural factors affecting climate change or causing climate change. Now coming to that important latitude. We have 0 degree as equator, 90 degree north is North Pole, 90 degree south is South Pole, and then between you have two major 23.5 degree as called Tropic of Cancer and 23.5 degree south is called Tropic of Capricorn. .5 degree north is called Arctic Circle and 66.5 degree south is called Antarctic Circle. Now I'm asking why this 23.5 degree north and south? Why not 23 or 24? Because of axial inclination, right? What does axial inclination do? Is the vertical rays of the sun remains it between the two tropics. It doesn't go beyond that, right? When Earth revolves, the vertical rays move from Tropic of Cancer to Capricorn and then comes back this way. So this is the zone where vertical rays of the sun exist within a year. And why this is the zone? Because of inclination, right? We'll discuss that. I'm just trying to help you learn this part. Why it is an important factor affecting climate change. What do you mean by climate change? Global warming. That's one part of climate change. What is climate? Increase or decrease in temperature. So that is morning climate, afternoon climate, and evening climate. That is weather. Change in due course of time. Like Hyderabad in December, Hyderabad in June, Hyderabad in March. Is it? Many years. What is weather? Change in? All of you know it. But I'm just expecting an intellectual definition of it. We very often talk about on phones and also today's weather is not good. Today's weather is bad. It's a great weather. Let's go out. Let's hang out. It's good weather. Right? If it is raining, it's good or bad? Sometimes it depends upon whether you have girlfriend or not. If you have, it is good. If you don't have, it's bad. So whether is good or bad depends. The mental map is suggesting you good weather or bad weather or normal weather. What are the criteria which comes to your mind to help with this decision? All of you know it. I'm asking what is the weather? How do you define weather? Day-to-day change in the temperature of a place. Right? Very close. Not fully defined. Now temperature is normal if it is the storm is there. There will be change in mind whether weather is good or not. Right? Humidity. Precipitation. Climate is the larger term, bigger term. Try it out. All the environmental factors. What is environment? So your surrounding is what right now? No, she's there, he's there, your chair is there, front is there. No, I'm not joking. I'm just telling you how to frame answers within your mind. Because you need to be technically correct. What is weather? It is atmospheric condition. Condition of the atmosphere. Now, go on. Okay, you are talking on the phone, you are saying that weather is very good. Define what do you mean by that? The sky is clear. Okay, fine. That means there is no cloud. Temperature is normal, fine. The sky is clear, means humidity, precipitation chances and all. Temperature, what else? If it is dusty, then it is not dusty. Right? Yes, wind speed. High speed of wind may not be liked by many. What else? Cyclones. Good or bad? Right? Thunderstorms. Right? Hailstorms. So, atmospheric condition. At a particular place, at a particular point of time, produced by the sum total of the climatic elements. Are you getting it? Like the atmospheric condition, weather is the sum total of atmospheric condition produced by the variety of climatic elements, including temperature, pressure, wind, humidity, whatever you call it, clouds, precipitation, etc. That is, weather is dynamic. Morning weather may be different, afternoon weather may be different, evening may be different, and night may be different. But climate is largely static. Average weather of a particular area for a longer period of time is called climate. Right? Any change in weather is normal. But any change in climate is a matter of debate and research. Because weather is dynamic. Climate is static. Climate of Hyderabad is very good. What do you mean by that? Say average temperature doesn't go 45, it's not scorchy heat. It's not extremely hot. Then it's not cold also. Like you might start wearing pullovers and all just after one rain, but it's not cold, real cold. If you want really to experience real cold, go to North India, go to Delhi in December, January month. Right? So it is normal. So you can say climate. Change in climate. Change in weather. Change in weather is normal. Change in climate is big deal. So when we say climate change, it's not only global warming, it's global cooling also. Right? That's why right now global warming and climate change are used interchangeably or just as synonyms, but it's wrong. Climate change, global warming is one component of climate change. Average weather, average climate. So any change in average climate is climate change. So it may go up and it may come down. The most important indicator is temperature. That's why we call global warming or global cooling. But it will not only temperature which will change, the entire climatic elements will change. But indicator that visible and easily experiences or easily measurable is temperature. So that's why we call it global warming or global cooling. Now come to this part. I hope we are clear about these two, weather and climate. If you are not saying anything, I'll believe that you are understanding. Like in Muslims, when nikah is conducted, marriage, the mullah will come and ask the girl, like qabul hai, you might have heard about it. Do you accept the groom with this? The girls are generally silent. They don't speak anything. Right? So mullah will say, khamoshi haan ki alamat hai. The silence is the indication of acceptance. Mubarak ho, shadi mubarak ho. Right? So she will not say anything. So it will be accepted as, okay, you are accepting it. Your silence is acceptance. You are not rejecting. Only they regret later on. So if you are silent, I'll believe that you are understanding. So keep on asking questions wherever you feel like. So this part, right now it is 23 and a half and 23 and a half. That means together we have 47-degree latitude where vertical rays of the sun travels. Wherever the vertical rays of the sun is there, the temperature will be higher. All of you know. If the larger area is covered by vertical rays, the earth average temperature will be higher. If it is smaller, the average temperature of the earth will be lower. So when it is lower inclination close to 22, it indicates global cooling, or it is a part of global cooling. If it is higher inclination, it is a part of global warming. That's why axial inclination or variation in axial inclination is an important natural factor affecting climate change. So this axial inclination is moving from 22 to 24.5. That's why we are in global warming period. In the history of Earth, the temperature graph has always gone like this. This is global warming, this is global cooling. Right? We'll read that last glacial age was Pleistocene glacial age, around 11,000 years before present. This is called last ice age. It lasted around 11,000 years. So this was the Pleistocene period. Now we are in this phase. So it will go at up to one of the natural factor, not all, but one of the natural factors is axial inclination, and we are moving towards it naturally. Right? When humans were not non-existent, even then the global warming and cooling was happening. Right? So humans give too much importance with respect to changing scenario of the climate. However, we have locally intensified it, spatially intensified it with respect to the pollution or the heating and the concretization of the surface and all. So at local level, human have really impacted, but global level, human doesn't have capacity actually to impact. So like save Earth, wrong word. You cannot save Earth. Save yourself. Right word. Save humanity. Right word. Because Earth doesn't need your help to save. Earth has its own capacity to save itself. Nothing will happen when 3, 4, 5 degrees Celsius temperature increases with respect to Earth. But everything will happen to humans. We will not be able to bear it. Or other species will not be able to bear it. The ecosystem destruction will take place. The functioning will be disturbed, and we might not have sufficient thing to function properly. The system we have developed. So, axis of the Earth is an imaginary line joining both the poles passing through the center of the Earth. Axis is not normal with respect to what? Sun. Right? It is inclined. Right? When it is inclined, it inclines from 22 to 24.5 degree. That variation in the inclination affects the global temperature. When the lower inclination, the inclination is lower, it leads to global cooling. Why? Because the aerial coverage of the vertical rays of the sun is lower. When it is more inclined, then the aerial coverage of the surface of the vertical rays of the sun is higher, hence the temperature is higher. That means higher the inclination, global warming. Lower inclination, global cooling. Anywhere you need any assistance, let me know. Right? Now, the axial inclination with respect to two things. Normal, 23.5. Orbital plane, 66.5. So, always check out the reference point in the examination. Very often they'll asking you, when the reference is orbital orbit of the earth, like this, right? If we are taking it from here, it is 66 and a half. If the reference point is here, 23 and a half. Both together will make 90 degree. Let's take earth right now here, right? So it should be like this. Take your head as sun, right? Right now inclined like this. It should be normally like this. Then it is perpendicular with respect to sun, but with respect to sun it is inclined. It should be like this, but it is inclined like this. So when we measure from the normal with respect to sun, it is 23.5 degree. Now it is revolving around you. Can you understand? Right? So this is the orbit of the earth, or we can say plane of the earth. So when you draw the orbit, this will be like this, orbit of the plane, right? So from the orbit it is, if you measure, 66.5 degree. So along with reference to orbital plane, earth is inclined at 66.5 degree. With reference to normal, it is inclined at 23.5 degree. So rotation on its own axis. One of the another property of the earth axis is parallelism. Parallelism. This is also called parallelism of the earth. Earth parallels means latitude. Parallelism is a property of axis. The axis of the earth, remains parallel to its previous position. Remains parallel to its previous position throughout the period of revolution. Throughout the period of revolution. That is called parallelism. The axial point directing or pointing towards a fixed star in the space. That star is called North Star. A very important property of the earth. Now what is it? Imagine this as a revolution. Imagine your head as sun and earth is revolving. Now the axis, right now the axis is here. So the next time when it is moving, it will be like this, parallel to its previous position. It will not be like this. It will always be parallel. Next time when it is there, it will be parallel. It will be parallel. So this axis point will be directed towards a star in the space, always, throughout the period of its revolution. This will be pointing in the space. It will not be visible from the closed surface, but it will always, this is called parallelism. The moment it changes, anything changes, that will create a lot of problem. Whatever phenomena we are having, day and night, season and all has to do something with parallelism also. That is how UPSC plays with. Which of the following is responsible for seasons? What is responsible for making seasons? Revolution. That is the least important thing. in making seasons. We'll discuss that. Right? Least important thing. But books write about that. Books do not have many enough space for that. When you see UPSC questions, they'll see you 1, 1, 2, 1, 2, 3, 1, 2, 3, 4, all, none kind of thing. Right? So you'll have to choose from there. So you need to understand. So one of the property of the earth axis is parallelism. Right? Till now what we have read? The shape of the earth, the latitudes, the longitudes, the great circle, right? The parallels, the meridians. Any term if you want me to define and rediscuss, please let me know. I'm just giving you a reference. Will be same? No, it won't. It is the inclination. Like right now, if you see the earth, right, as a sun, right, the sun's rays travel straight path. So it is right now inclined, and the sun's rays will be somewhere above the equator, the vertical I'm talking about, right now, right? At a particular latitude it will be. Hope we can understand? Now it is moving like this way. So it will either come down or go up from there. So the maximum movement is at the angle of inclination. Now imagine if it is not inclined. It's perfectly like this, 0 degree inclination. Now see your eye at a particular point, and now let it revolve. You won't have any change. The vertical rays will always be here at the equator, right? Now, right now, look at here, if it is inclined, the vertical rays is above the equator. Now go that part. The vertical rays will be below the equator. And when you go in the middle of that, vertical rays will be at the equator. So the changing position of the vertical rays will be in accordance with the Earth's inclination. So if Earth is inclined 23.5 degree, right now if it is at equator, it will go towards 23.5, will come back to equator, will go through this and will come back to equator. If it is just 1 degree inclined, it will go from 0 to 1, come back to 0, 0 to 1, come back to 0. If it is 0 degree inclined, it will remain constant at equator. Super clear? Right? Anything else? Let me know. Then we started rotation. What is rotation? A spinning of earth on its own axis. Right? We tried to learn two properties of the axis. One is parallelism. When the axis of the earth remains parallel to its previous position throughout the period of its revolution. Right? And another one is axial inclination. With two reference points, the inclination is two different, like 23.5 degree when we take the reference from normal, and 66.5 degree if the reference is earth plane or orbital plane. Right? Then axis do play an important role, like inclination in climate change. Right? When inclination is lower, it is global cooling. When inclination is higher, it is global warming. Right? We are in the phase of global warming because earth inclination is one of the natural factor, not the only factor. Inclination is towards 24. Right? We'll take a break. Any question? Let me know. White dwarf, one of the dead stars. Dead stars are categorized into three groups: white dwarf, neutrinos, and a black hole. What is a black hole? It's a dead star. What is neutrinos? Dead star. White dwarf, dead stars. Dead stars are put into three categories based on its density. Like, see, we have millions of billions of stars in the universe. All the stars may not be of similar size, just like humans. Let's say suppose we make graves for humans after their death. So different height people will have different length of the same ways, the different star will have different density, and once they die, they will make different density dead stars. So if they have lowest density, generally the stars which are smaller than the sun will be transformed into white dwarf. Roughly around sun and slightly bigger than that will make neutrinos. And much, much bigger than that, the largest star only get converted into black hole. And the very fast rotating neutrinos are called pulsars. The rotation speed is very high. How do we identify it? No, it might not enter into other solar system, but the other solar system might enter into its orbit or the what you call magnetic sphere. Different planets have different magnetic spheres. So if let's say suppose the solar system comes very close to a black hole, then it will start eating out entire. Solar system gravity may not be able to make the resistance enough to maintain its space going. So we'll be flying. We'll be flying out of Earth and going into the black hole. The death of all humans in one go. Imagine that death. You will love it. Here is a black hole, suppose, right? Everything is rotating and revolving, right? So if this is, let's say, suppose this is the path or vital path of the black hole, or the entire system of the black hole, which is now collapsed in one single body. Now black hole is here. Then other body might be like somewhere here, this way. Coincidentally, if it happens that this star system is right here, closest to black hole. Now this star system had its own family. Just like in our case, Sun, Mercury, Venus, and then Pluto, Neptune and all this side. So it might start eating out, taking this. So long it is here. The moment it could reach here, then the distance and all will be varying. So it may just eat out the outer boundary. But if it is close enough, it may eat out the planets. Close enough and stays for longer for some reason, it might, the entire star system might be eaten. And that is how, in fact, black holes, the location of black holes are established. Why it is called black? It is not visible. Even with the modern scientific tools, it is not visible. Why it is not visible? Because of its extremely high gravity, it doesn't allow the light falling on it to reflect back from here. Anything, the concept of visibility depends upon this thing. Light is falling on this board, and from there it comes to our eyes. That's why we can see that board. You might have read in 6th class, 7th class physics, right? So if that light is falling on this board, and all the light is being absorbed by this board, we will not be able to see this board. That happens with the black hole. It is not visible because it doesn't allow the light falling on it to reflect back. That's why it is called black. Hole. The literal meaning of hole we understand, right? Pit. So it is called hole because of this, right? Here you have black hole, and let's say suppose there is a body right here, and it is far enough, but only have higher gravity. This black hole has enough gravity to pull its small part, upper part. Let's say suppose Earth is close to a black hole, so the upper sedimentary rocks might be pulled, or there may be gaseous layer of atmosphere might be pulled. So that sedimentary rocks will appear moving in this direction. It will be visible till here, and the moment it reaches the black hole, it disappears. So that it acts as a dustbin or a hole where you can put everything. So this is black because it's not visible, hole because it absorbs everything around. And that's how you can locate that a black hole exists, because flare will be visible till here and then it becomes invisible. Anything coming in this direction will be visible till here and then becomes invisible. So that is how scientists locate that black hole exists here. Anything else? Speed of rotation. Duration, I hope we know that. What the duration of rotation is? 24 hours, one complete rotation roughly around 24 hours. Speed. Will it vary or will remain constant? The speed of rotation of different part of the earth will be constant or will vary? Will vary. Why? It will remain constant. Why? What is the formula of speed? Distance upon time, right? Is there any variation in distance or time here? Time is constant, 24 hour. Right? Distance is constant or varying. So speed is equal to distance upon time. Time is constant. So can we say speed is directly proportional to the distance? Right? Because time is constant. Right? Now what is distance? The circumference. Because rotation is along the latitude. Now imagine that equator. An object or a place located on the equator has to cover the maximum distance in 24 hours. If you keep on going, the distance decreases. The distance decreases. At the pole, it is just a point. Imagine the pole, a point covering this much in 24 hours. Right? This area, let's say this place, covering the maximum distance in 24 hours. So when the distance keeps on decreasing, the speed of rotation will also decrease. Any doubt? Might not exist at all. There will be 24 hours day-night phenomena you might have heard. Right? You are asking about Norway. Can you understand now? Look at your head as sun. Can you see Norway right now? Or something, anything is close to pole. You will not be able to see this. It will not be out of your sight and this will not be under your sight. 24 hours night, 24 hours day. So a part of the earth will receive 24 hours night, 24 hours day because of that. Again the inclination. Right? So speed is directly proportional to the distance and that leads to maximum speed at equator keep on decreasing and become minimum, almost minimum, 0 at pole. Both the sides, the speed of rotation keeps on decreasing towards the pole from the equator because of the decreasing circumference or decreasing distance as the time is constant. Anywhere, keep on asking. The consequences of rotation. The most important consequence. Day, night phenomena. Happening at any place is because of rotation. Right? Generally, half lit and next another half dark. The dividing line is called circle of illumination. So we can easily understand. Again, imagine your head as sun. You can see only half of it right now. So half will be day and next half will be night. It will keep on rotating and keep on bringing the darker side and the light and the lighter side and the darkness. That's how we have changing time also. Right now see the rotation morning, noon, evening, midnight. Now this morning will be transferring into noon, evening, night. So the change in the time of a place is also due to rotation. Changing time at a place is also due to rotation. Then the next one is shape of the earth. We already have talked about. Shape of the earth is due to rotation. Then one of the most important aspects is Coriolis force. Coriolis force due to rotation, especially the variation in the speed. Write down. It is an apparent force, Coriolis force. It is an apparent force produced because of the rotation of the earth. It is an apparent force produced because of the rotation of the earth which causes produced because of the rotation of the earth which causes deflection in the direction of the moving fluids, which causes deflection in the direction of the moving fluids. Rightward in the northern hemisphere, moving fluids rightward in the northern hemisphere, rightward in the northern hemisphere and leftward in the southern hemisphere, and leftward in the southern hemisphere from the point of origin. Leftward in the southern hemisphere from the point of origin. It affects only the direction. It affects only the direction. The value of Coriolis force, is affected by latitude and the speed of the moving fluid. Latitude, the value of Coriolis force is affected by the latitude and the moving fluids. Speed of the moving fluids. It is directly proportional to the latitude and the speed. It is directly proportional to the latitude and the speed. In other words, it is 0 at equator and continuously increases to attain maxima, and continuously increases to attain maxima at equator, at pole, sorry. Increases to attain its maxima at poles. Similarly, it increases with the increasing speed of the wind or ocean currents. It increases with the increasing speed of the wind and ocean current and decreases. It increases with the increasing speed of the wind and the ocean currents and decreases with the decreasing speed. Now, technically it is going into the physics and deeper like angular momentum and all. Just as a layman, let's see, starting from Hyderabad to Delhi, imagining that both are located on the same longitude, right? Now Earth is rotating. So let's say a flight started here at 11 a.m. and supposed to reach at 1 p.m. Right? That means it is taking how much? 2 hours. Right? So it is started at 11 a.m. Delhi is here at 11 a.m. But at 1 p.m. Delhi will not be here because Earth is rotating. Now Delhi will be shifting 1/12 of the circumference. 24 hours, one complete rotation. In 2 hours it will be shifting somewhere. And it turns, the direction is west to east. The rotational direction is west to east, right? So it will be moving this way and the Delhi will be at 1 p.m. Delhi will be here. Now if you plot a flight path, that flight path will be something like this. Any doubt? So this is what we call Coriolis force. This is not a real force. And it starts only with when the object is moving. Right? So this is how the rotation affects the direction of the motion of the wind. So if a wind has started from here, suppose this is high pressure and this is low pressure. So wind should start and move like this. But it will not move like this because of Coriolis force. So it will be forced to turn rightward, like this, from the point of origin. In the northern hemisphere, and exactly in the same manner, leftward in the southern hemisphere, both from point of origin. So what is the Coriolis force? It is an apparent force produced because of the rotation of the earth. Right? What does it affect? The direction of the moving fluids, both liquid and gases, especially in geography, winds and ocean currents. So from anywhere it has started, this direction, they'll move this way in the northern hemisphere. If it has moved this way in the southern hemisphere. Always leftward in southern hemisphere from the point of origin and rightward in the northern hemisphere from the point of origin. Right? Its value is affected by two factors. Right? Speed of rotation, if it's seen in terms of, so 0 degree has the maximum speed of rotation, but it is minimum at equator. Right? And it goes to increase maximum at poles because deflection will be higher. Angular momentum, all of you must have read. Conservation of angular momentum. No? Have you ever let the a top or a ball attached with a string played with it like this, or at least you must have seen if you are extremely nice cute baby, right? So if it is rotating, so long it is rotating with the same string length, the moment you stop it, the string will keep on coming and rolling around your finger, but the speed of the ball will keep on increasing. Thoda thoda. It is the radius, right? When the radius increases, speed will decrease. When the radius decreases, speed will increase. Conservation of angular momentum omega r, right? So if the speed of the rotation is lesser, the deflection will be higher. If the speed of rotation is higher, the deflection will be lesser. If you understood, it is fine. If you didn't, it is very fine. Simply now learn, UPSC will ask you this thing, that value of Coriolis force, 0 at equator, maximum at pole. Right? That's one aspect. Value of Coriolis force directly proportional to the speed of the moving fluid, let's say wind. So there are two factors which affects the value of the Coriolis force. One is the location, another one is the speed. Next consequence is tides. Tides are the alternate rise and fall in the ocean water due to the gravitational pull of the moon and the sun. Now imagine your head as moon. अभी तक सन था, अब चांद हो गए तुम लोग, राइट? बहुत लोगों ने कहा भी होगा. Now imagine this, your head is sun, moon, and the water is being pulled towards you. This is what we call tide. We'll discuss in detail in oceanography. Right now, this is what you call tide. Now, if the earth is not rotating, the tide will remain locationally fixed. Now, earth is rotating and taking this place away from your influence, there will be fall. So, rise is due to gravitational pull, fall is due to rotation. So, the rotation also plays in basic properties of tidal movement of water or tides in ocean. Primarily fall. So alternate rise and fall in ocean water is called tide. So rise is due to gravitational pull and fall is due to rotation. Coming back, don't worry. We'll start our discussion tomorrow with revolution. I hope you have brought a test with you. Open it. Multifarious rule. Direct question in prelims. 3 to 8 questions. That variation is there in prelims, direct question. Then it will help you understand international relation, IR. Very handy. For example, if you are learning Tapi pipeline, you know where Tajikistan is there, Pakistan is there, Iran is there. So you can easily imagine it, right? If you're learning about Indo-Russia relationship, then there comes in between something. So if you know the location, if you are having West Asia or Southeast Asia, so everything about IR, it will be very, very extremely handy to learn and remember and memorize. The same is true about current affairs. Most of the current affairs, if you're looking through Atlas, it will be very easy for you to memorize and produce in the examination hall. Always remember, it's not only about memory or memorizing thing. It's also about producing the same under the pressure in that 2 hours, 3 hours in the examination hall in prelims and mains, right? So that will help you locate and recall. Then drawing maps in the mains will always give you edge over others. Again, half mark, 1 mark. That's the struggle later on. Once you get selected, 5 marks and 6 marks can make a difference of 100 ranks. So never underestimate this half mark or 1 mark, right? So this is the role of the Atlas in UPSC preparation. It's not only about direct questions asked in prelims. Then second aspect is, generally we have, on Atlas we have continents and oceans. How many continents we have? 7 continents. The largest one, Asia. Second largest, Africa. I'm telling you. Africa. Third largest, North America. Fourth largest, South America. Fifth, Europe or Antarctic. Fifth is Antarctic. Sixth is Europe. And seventh is Australia. I repeat it. First is Asia. Second, Africa. Third, North America. Fourth, South America. Fifth, Antarctica. Sixth, Europe. And seventh, Australia. You must have seen Australia. So this is located as an island. So that's also called Oceania or island continent. Right? Population wise, largest is Asia. Second largest is Africa nowadays. Earlier it was Europe, but now Africa. Third largest is Europe. Then North America, South America, Australia, and Antarctica will not come into shoal. How many oceans do we have? 5. Right? So have you heard about Saat Samandar Paar Mein Tere Piche Piche Aa Gayi? There is a song, Hindi song. 7 seas. The concept of 7 seas in Indian geography. Why 5? What are those 5? Pacific, Atlantic, Indian, Arctic, Southern Ocean, right? There are only 3 oceans. Pacific, Indian and Arctic, Atlantic. Rest all are extension. Technically, by definition, there are only 3 oceans. Right? Rest all are extension of that, which are generally called seas, and the smaller one is called marginal seas. But the ocean-wise, only 3 oceans. Right? Now you have several terms which you will come across when the continental part is intruding or appear to be intruding into the oceanic areas. So you have the term peninsula. Right? Peninsula, cape. Right? Another is subcontinent. Right? Then you have stomachs. When the continents are intruding into the oceanic water areas. What is a peninsula? What is a continent? Landmass. And what is an island? That is also landmass. What is a continent? A large landmass with distinctive geographical boundary. Extremely large landmass with distinctive geographical boundary. Geographical boundary. Cultural homogeneity, largely. Or we can say a continent is a very big island. Right? A continent is a very big island, we can say that. Island also have its geographical boundary, but they are smaller, so we call it island. What is a subcontinent? Which has basic characteristics of a continent, but is not big enough to be called a continent. Indian subcontinent. Right? Hope we all know we have Himalayas here. Right? And then we have oceans. So this has a clear-cut geographical boundary on the north and the east, west and south, yet not big enough to be called a continent. So that's why we call it subcontinent, smaller continent, reflecting the characteristics like India or South Asia. If you see, culturally we are kind of globe. There are culture within the cultures. There are nations within the nations. We are also the same, a country within the countries. There are several countries within a country itself. Tamil, Telugu, Kannada, Bihari, Odia, UP. A lot of distinctive culture, right? So diversity. So it reflects or it has all the basic characteristics of a continent, yet not big enough to be called a continent. So we call it subcontinent. Right, now peninsula. Island is all sides water, surrounded from all sides by water. Peninsula is three sides. Three sides. Right, peninsular India. Look at this peninsular India. Right, so water, 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 three sides. So this is called peninsula. A large one is called peninsula, or a smaller peninsula is called cape. Is called cape. Cape of Comorin. In our case, Cape of Comorin. Look at here. This is also a peninsula, but not big enough. This is a peninsula, but small ones will call Cape of Comorin. In Africa, there is Cape of Good Hope. Hope you understand. Three sides, surrounded with water, we call it peninsula. Smaller peninsula, we call it cape. Isthmus is narrow piece of land joining two larger pieces of land. Land 1, land 2. We'll call it isthmus. Panama Isthmus. You might have read in current affairs Kra Isthmus, because China is making a canal there, Kra Isthmus, joining Malaysia and Thailand. So this is called isthmus. So you define isthmus, a narrow piece of land joining two large land masses or separating two water bodies. Both are isthmus. Even I didn't get it. Isthmus is a narrow piece of land. Okay, I'll show you. Look at here, this land. This is a very narrow piece of land. There is a big on North America, South America, a small piece. This is isthmus, Panama Isthmus. So a narrow stretch of land joining two land masses or separating two water bodies. Similarly, you have Kra Isthmus here. Look at this is called Kra Isthmus. or we can see this part, right? So you have large landmass joined by very narrow stretch, Isthmus. It is joining or separating, both the cases. That's called isthmus. And then the case of ocean entering into the continent, you have the term Gulf base. Gulf and base. You have term creek backwaters. Here itself will take lagoons also. Creek and backwaters. Gulf base, larger intrusion of ocean water, smaller intrusion of ocean water. Now, what is a gulf and bay? Technically, a gulf is one like which joins the mother body with very narrow stretch. Like if this is a water body and you are sitting in the ocean, this side it is land. If it is joined like this, a narrow stretch, this will be called a gulf. This is base. Let me help you refresh if you understand. How many of you understand couplets? Don't enjoy poetry? Even if you enjoy, you will not be able to tell it, right? So some of you might enjoy it. Let me give you a situation. Right now, I'm a ganja kind of person. But it was not always like that, right? I had a lot of hair, ponytail and all in my graduation time. So the photos are different, present day photos and those photos. It happens once that when my son saw my older photos kept on the table, he asked his mother, who is he? Right? So my wife is telling him, he is your father. So he got surprised. Now keep that in mind and listen to this couplet. कहा बेटे ने अपनी मां को एक तस्वीर दिखलाकर. कहा बेटे ने अपनी मां को एक तस्वीर दिखलाकर, ये किसने नाम मेरे बाप का फोटो पे लिखा है. कहा बेटे ने अपनी मां को एक तस्वीर दिखलाकर, ये किसने नाम मेरे बाप का फोटो पे लिखा है. वो बोली ये तुम्हारे अब्बा हैं. वो बोली ये तुम्हारे अब्बा हैं. बेटे ने पूछा फिर तुम्हारे साथ कमरे में वो गंजा कौन रहता है. So good number of you understood it, huh? That's good. That's beautiful. Now come, you will understand it in a better way. We are trying to differentiate between Gulf, bays and lagoons. Can you see this spot? Water body. What is called? Bay of Bengal. Bay of, look at the shape. Bays. Right? I'm showing you Persian Gulf. Look at this Persian Gulf. If you can see in the atlas also, this is Persian Gulf. Take out the world map. Open the world map. Any world map. World map. Now check out Persian Gulf. Around West Asia and Bay of Bengal, you will have the difference. Good. Look at any world map. This is Bay of Bengal and this is Persian Gulf. Look at it And now I'm trying to explain it to you. If there is a water body which is something like this is water body, right? And then this is larger water bodies, mother ocean. Don't treat it as human. So if a smaller water body is joined with its mother body through a narrow stretch, this is called strait. You must have heard about strait and channels. A broader straits are called channel. English channel. Right. So this is Gulf. This will be Gulf. That's what I was trying to help you this way. If the shape is like this, which is closing near the mouth, the joining point, it will be Gulf. When it is opening, open mouth, it will be base. समझे तो ठीक है, नहीं समझे तो भी ठीक है. लोड नहीं लेना है किसी चीज का. Don't take pressure, too much pressure. Right? Then we have creeks and backwaters. Both we are well known for. Right? If you have a coastal area, right, and if the intrusion of water is like this, very narrow, perpendicular to the coast, like if you draw this, go ahead. I haven't defined it yet. Have patience. So, this is, okay, Gulf, you understand? Smaller Gulf is big, are lagoons. Let's suppose you have a coastal area. This is a lagoon. Chilka Lake is a lagoon. If you have much bigger Gulf, this is the coast. Lagoon. Base. Base, Gulf, lagoon. Lagoon is a lake which is connected to ocean, as simple as that. And if it is big one, there will be Gulf. You can say extremely large lake or lagoon is Gulf. Gulf with wide open mouth, base. Are we clear? Now creeks and backwaters, right? So creeks are perpendicular to the coast, this way. Narrow intrusion of water into the continent, perpendicular to the coast. It's called creeks. And these are backwaters, parallel to the coast. Backwaters, creeks. Water coming from back. Kerala is very famous for backwaters. Gujarat is very famous for creeks. Like backwater in our case is called Kayals. Oh, we are clear. So the normal oceanic activities or undulations, waves, storms will not affect the backwaters, but will affect the creeks. Are we understanding it? Anything, let's suppose waves. So waves will enter directly into it will not enter directly because they are protected. That's why backwaters are important fishing grounds. They are important site for water sports. Kerala, you have boat races, very famous. So they are done in backwaters because they are sure about that oceanic activities or ocean storms will not affect them. That's for backwater. And there is a connectivity, so there is an intrusion of fresh water. So this is brackish water. You have fresh water, we have oceanic water, saline water, we have brackish water. Brackish water when fresh is joining with saline water, ocean water. So these are brackish water. So fishes and all other oceanic organisms will enter into this area, will reside there, right? Maybe breathe there or breed also. So that becomes a very important biodiversity spots in oceanic areas. Hope you understand? We have straight channels. Are you clear? A counterpart of straight in the land is called thumas. Gulf, narrow down. Bays, wide open. Smaller gulf, lagoons. Right? Creeks perpendicular to the coast, backwaters parallel to the coast. Backwaters in our case is known as Kayals, famous in Kerala. Creeks, famous. Now, we have, I have the a process of learning or memorizing atlas. You just to follow that, right? So today we are going to have the experience of how we are going to proceed with this atlas in the coming days, right? So the smallest continent or the easiest to do is South America. Open South America. Now, watch it the way I am telling you. Just behave like a small kid, 6th class, 7th class. Watch from French Guiana. Can you see on the top right? Right? Right to left. French Guiana, Suriname. Guyana, Venezuela. Don't look at my face. Watch the atlas. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. In that sequence, watch it. Try to see the capital city and the location of the capital city with respect to coastal location or interior location. Or the major cities also, which you might have heard about, like Rio de Janeiro, Sao Paulo. Just try to watch it. Now, don't look at the atlas. Now look at me. Don't watch the atlas in between till I tell you to do so. Memorizing atlas is an art. Right? Just repeat with me. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. Watch the atlas. Fast. Watch the atlas. Raise your head. Now look at me. This much time. Now, when we are doing it right now onward, when we are just recalling that, don't just recall the names. Recall the location also. We are getting it. And be the part of the process. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. One more time. French Guiana, Suriname, Guyana. Don't see the atlas. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. Now you say, speak, I'll repeat. And try it. It is a process. Don't be shy. Just French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. One more time. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. One more time. Suriname, Venezuela, Ecuador, Chile, Uruguay, Bolivia. One more time. Suriname, Venezuela, Ecuador, Chile, Uruguay, Bolivia. One more time. Venezuela, Ecuador, Uruguay. One more time. Venezuela, Ecuador, last time. Ecuador, Paraguay. Can we go backside? Brazil, Bolivia, Paraguay, Uruguay, Chile, Peru, Ecuador, Colombia, Venezuela, Guyana, Suriname, French Guiana. Brazil, Bolivia, Paraguay, Argentina, Chile, Peru, Ecuador, Venezuela, Guyana, Suriname, French Guiana. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Argentina, Uruguay, Paraguay, Bolivia, Brazil. Brazil, Bolivia, Paraguay, Uruguay, Argentina, Chile, Peru, Ecuador, Colombia, Venezuela, Guyana, Suriname, French Guiana. French Guiana, Colombia, Uruguay, Brazil. वापस Brazil, Bolivia, Argentina, Guyana. Just 6 minutes. One continent is finished. Right? So be a part of the process. Watch it for the next 1 minute only. And very fast. Don't get stuck at one place. Very fast watch it. Let your eyes cover the entire continent. And go through it. 30 seconds, 30 times. Now raise your head. Just recall the total map, whole map. Don't see the atlas in between even if you are tempted. Right? I trust your honesty till you become an IS officer. I'm asking question, just you say yes or no. Argentina will share its border with Brazil. Yes or no? Don't see the atlas. Okay, don't see the atlas, yes or no, I don't care. Bolivia will share its border with Argentina. Don't see the atlas, right? Uruguay will share its border with Paraguay. Watch the atlas. Make it very fast. That's how the questions are framed. Raise your head. Don't get stuck there. Ecuador will share its border with Brazil. No? Don't see the atlas. That's one condition. Because this is for you only. I can see you watching the atlas. Always remember that. I may not tell you anything because you are grown up babies. I can't scold you. That too in the class. So, but don't see the atlas because this will not be helping you. Ecuador will share its border with Brazil. Colombia. Just recall, when I'm saying you Colombia, just recall the surroundings. Colombia will share its border with Peru. No? Watch it. Raise your head. Quickly. Come back. Don't get stuck there. That's the process of long-term memory. Don't get stuck there. If your eyes are too longer there, you will not be able to remember it. Once you have seen it, now raise it and recall it. Anything you want to memorize, do this way. You'll have long-term memory. Because now you're recalling with the figure. Name you can forget. Figure you won't forget. So I'm trying to help you remember the figure, not the name. Like if South America blank map is put before you, you can pinpoint that this will be Brazil, roughly. Not exactly, you don't need to plot the Brazil area, but you will see that, okay, this is Brazil, this is Argentina, this is Uruguay, this is Paraguay. So that's how you are supposed to do it. Let's do it together one more time. French Guiana, Suriname, Guyana, Venezuela, Colombia, Ecuador, Peru, Chile, Uruguay, Bolivia, Brazil, Paraguay, Argentina, Chile, Venezuela, Guyana. That's all for the day. Thank you and take care.